Hello everyone. In the last class we have studied electric dipole. So today in this class we will study about electric dipole derivations. So electric field of an electric dipole. Our first derivation is electric dipole for points on the axial line. So you can just look at the diagram. So positive charge, negative charge. So if it is positive and negative charge, both can attract. For negative charge, the electric field for negative charge, so you can take any of the test charge. So for negative charge, test charge is always positive, then it can attract. So this is the arrow mark, then it shows the electric field minus Q. Then for positive charge, test charge is also positive. Positive means repulsion. So repulsion means it is direction towards away. So then it shows electric field plus Q. So once again, so here positive charge, negative charge. For positive charge, you can take any of the test charge because electric field. Positive charge, test charge, both are repulsion. So then it shows the direction, repulsion force E plus Q. Minus Q, test charge means positive, positive minus means attraction. So electric field is towards the charge. So it shows one is away, one is towards. And the distance from P to O, that is, here I have taken the distance from charge plus Q to minus Q as here R, this distance, and this distance as G. So now we have to write the electric field for positive charge and negative charge. So electric field for negative charge, we know the formula of electric field 1 by 4 pi epsilon naught Q by R square. So for electric field minus Q is equal to, you can write minus K means 1 by 4 pi epsilon naught Q divided by R square. So here the distance is 2. So this PQ, P2, this distance is R and that distance is A. So that's why R plus A whole square into P cap and E plus Q. So E plus Q, K means 1 by 4 pi epsilon naught. So K into Q divided by towards right. So R minus A whole square into P cap. Then, so you have to add both of the electric field. So that is E is equal to, or E total is equal to E plus Q plus E minus Q. So that is K into, you can take outside constant. So K is 1 by 4 pi epsilon naught or Q by 4 pi epsilon naught. So remaining 1 by R minus A whole square minus 1 by R plus A whole square into P cap. Then, so E vector is equal to K Q. K means 1 by 4 pi epsilon naught, that is common. Then, so here you just cross multiply 1 into R plus A whole square minus R minus A whole square divided by R minus A whole square into R plus A whole square. So R minus A whole square into R plus A whole square is R square minus A square whole square. That is the formula. And so if you cross multiply, you will get 4AR. Here you will get 4AR. So that is R minus A whole square into R plus A whole square. That is R square minus A square whole square. So you know the formula of A plus B whole square into A minus B. So first cross multiply both of that. So you will get in the numerator R plus A whole square. R plus A whole square means R square. So here K means 1 by 4 pi epsilon naught into Q. So cross multiplication R plus A whole square minus R minus A whole square divided by R minus A whole square into R plus A whole square is R square minus A square whole square. So this is the formula. So now continue. Q by 4 pi epsilon naught into, what is R plus A whole square? So R plus A whole square is R square plus A square plus 2AR minus R minus A whole square, R square plus A square minus 2AR divided by R square minus a square whole square. So the next step is q by 4 pi epsilon naught r square plus a square plus 2ar minus into r square minus into plus minus a square minus into minus plus 2ar divided by r square minus a square whole square. Now plus r square minus r square get cancelled, plus a square minus a square gets cancelled. So what is the remaining term? Q by 4 pi epsilon naught into 2ar 4ar 2ar plus 2ar 4ar divided by r square minus a square whole square. Okay, so then here you can see, so 2 into 2 4ar divided by r square minus a square whole square into p cap. So we know the formula 2a into q, 2a into q. So I can write 4ar in 4ar 2 into 2. 4 means I can write it as 2 into 2. Then 2aq is p cap, p vector. So I can write it as 2aq is dipole moment, we know that. So that is p vector. So what is the formula? What is the final expression? 2kpr divided by r square minus a square whole square. Yes, here we know that the distance r is greater than a. So if the distance r is greater than a, so we have to neglect this term, that is a term. If you neglect this term, so this you will get r square whole square. So r square whole square means r power 4 we will get. So then 1r will get cancelled. Then what is the remaining? This becomes r cube. So what is the final expression? So the last step is now 2k p vector divided by r cube. So the final expression is E vector is equal to 2k p vector divided by r cube. So this is the final expression for electric field for points on an axial line. So this is the derivation. Yes, and the next topic is electric field for the points on the equatorial line. So now you can see the points. So this is a diagram. This is a diagram for equatorial line. So here we know that the electric dipole is always started from negative to positive. So here I have taken charges from negative to positive. Okay, so here negative I have taken, here positive I have taken. And we know the electric dipole formula, that is 2a into q. So here what is the meaning of electric dipole? It is a pair of two equal and opposite charges separated by a small distance. So plus q and minus q. It is always started from minus q to plus q, separated by the distance 2a. Okay, so we have to take minus 2 to plus q. So here minus is there. So minus means test charge. This is a test charge. So minus plus it is attraction. So attraction means you have to show the direction this side. Then plus and test charge is also plus. So plus is repulsion. So I have to show the direction of this. So then we have to write the resultant vectors here. So we have to write the resultant, that is E plus Q. So E minus Q, E plus Q. Okay. So now we have to resolve this diagram. So how to resolve the components? So I'll explain the diagram. So minus Q2 plus Q. Okay. So now join the line. The distance is 2a. Okay. So minus Q means, so first make bisector line. Then so join both the lines. Then this is minus, here is the point, that is the test charge, and minus plus attraction shows this direction. Then plus it shows the direction this side. So that is E plus Q, and this is E minus Q. So we have to write the resultant components for this. Okay, so then we have to resolve these components. So this is E resultant. Okay, so now if any one of the inclined vector is there, we can make two components of vector. One is horizontal and one is vertical. And here also one of the inclined is there, so we can make it as. So we have to resolve these components. Then vertical is E sin theta, E sin theta. So you can write it as E1, no problem. Then this is E1 cos theta, E2 cos theta. So both are opposite, so it cancel each other. So we will get E1 cos theta, E2 cos theta. Okay, so by this diagram we have to resolve all these things. We have to write these parameters first. Then this is dipole, the distance is 2e. Okay, so now we have to start what is AP. So you can take this AP and BP distance. So we know the distance is r. In the last derivation we did r plus a whole square. So that I can write it as root of r square plus a square. Then E minus Q. First we have to find out along BP. Okay, so what is the formula for electric field? E is equal to 1 by 4 pi epsilon naught Q by r square. Okay, so that is electric field due to negative charge. That is K means 1 by 4 pi epsilon naught KQ divided by BP square, BP whole square. Okay, BP whole square. This distance is, okay, this distance is r square, this distance is a. So I can take this as r plus a whole square. Then so now, so what is electric field? 1 by 4 pi epsilon naught Q by r square. So that is I have written it as K. So then divided by Q by r square. So the distance is BP square. BP, the distance of P is O is r, and here from B to A is A. So that's why r plus a whole square. Okay, so that is r square plus a square. Then E minus Q, that is E plus Q, that is 1 by 4 pi epsilon naught Q by r square. So plus Q, that is AP whole square. So AP whole square is KQ by same r square plus whole square. Yes. So we have resolved the components. So from the vertical components we have to solve this. Okay. So E plus Q sin theta and E minus Q sin theta. So both will get cancelled. Why? Because they both are vertical components. If they both are vertical components, opposite is there. So we can cancel. Then we will get E vertical is 0. So this one. This we have to cancel. Then, so after that we have to prove E horizontal. So now you can see. So E is equal to horizontal component minus of E plus Q plus E minus Q cos theta into P cap. That is, we can write it as E plus Q, that is 2 E cos theta. Okay, so now we will get, so we can write it as 2 KQ divided by r square plus a square cos theta into P cap. So next, continue. E vector is equal to, so here we will get, so two horizontal components, that is E resultant vector is equal to E1 cos theta plus E2 cos theta, horizontal. This one and this one we have to take. So it becomes, this I can consider it as E1. Why? Because they both are same. That is E1, 2E1 cos theta. 2E1 cos theta. So ER is equal to 2 into, what is electric field? 1 by 4 pi epsilon naught Q divided by r square plus a square into cos theta. Okay, so now we will get cos theta is, this cos theta is 2 into 4 pi epsilon naught. Okay, so A divided by r plus a whole square. Cos theta means, cos theta we have to resolve from this. So cos theta is A divided by r square plus a square. So now, so A divided by r square plus a square into q by r square plus a square whole power 3 by 2. Sorry, 1 by 2. Okay, so 1 by 2 into, 1 by 2 plus 1 whole power 3 by 2. So that is ER is equal to 1 by 4 pi epsilon naught A divided by r square plus a square whole power 3 by 2. So here r is greater than a. So here we should neglect this term a. Okay, then r square get cancelled, then the remaining thing is r cube. So now the final expression is E is equal to 1 by 4 pi epsilon naught p divided by r cube. So what is the final expression? E vector is equal to 1 by 4 pi epsilon naught p divided by r cube. Okay, this is the final expression. So vector form means we have to write the unit vector, that is p cap. So the final expression is E is equal to 1 by 4 pi epsilon naught, p is 2a into q. So this is all about this derivation. So in the last class we have studied about two derivation. One is axial line, electric field due to a point and axial line, and equatorial line. So in this class we will studied about torque dipole in a uniform external electric field. So here you can see in this diagram, here I have taken the uniform electric field. So on the uniform electric field you can take dipole. That is, we know that. So I am going to place the dipole like this, minus to positive. So we know the definition of electric dipole. So two equal and opposite charges and separated by the distance a, and also it is always started from negative to positive. So that is minus q and plus q. So I am going to place this dipole on the uniform electric field. So here we will get, so when you place the electric dipole, this is positive. Okay, so this is, we know that electric field always started from positive to negative. Dipole is negative to positive. So here if you place an electric dipole on the uniform electric field like this, minus to plus. Okay, so we know that electric field started from positive to negative. So plus attract towards this and minus attract towards the positive charge. Then it makes an angle theta. When you place an electric dipole on a uniform magnetic field, this dipole started behaving like a torque. We know that torque means rotation. So here we can see the derivation, that is the net force on the dipole is 0. That is, we know that here E F net is equal to plus Q E plus minus QE is equal to 0. Then what is torque? We know the formula of torque, that is RF sin theta. RF sin theta. So that is torque is equal to, so what is RF? So that is, we know that from the dipole, QE into 2A sin theta. So QE 2A sin theta is, the torque is equal to, will get PE sin theta. Why? Because we know 2A into Q is P, that is electric dipole moment. So then it is about to minus Q charge. So then we will get the final expression sin theta. So that is torque is equal to, sin theta means cross, that is P vector into E vector. So what is the torque? V vector into E vector. So its direction is normal to the plane of the paper, it going into it. So the torque will tend to align the dipole with the electric field always when the electric dipole aligned with the electric field when the torque is 0. So this is the expression for torque in a uniform electric field. Yes, this is an important point. So when P vector or dipole is parallel to the E vector, means when you take a uniform electric field and if it is parallel, you can place the dipole on, so you can see the dipole here. So if you place a electric dipole in a uniform electric field parallel, so you will get that the direction increases the field and the direction of net force is in this direction. Then when P is parallel to electric field, this direction it will show. So if it is parallel, if both are parallel, it shows the direction increasing the field. So then it shows the direction opposite. So you can see like this, it shows the direction opposite. So now we can see some problems. So an electric dipole with the dipole moment 4 into 10 power minus 9 centimeter is aligned at 30 degree with the direction of uniform electric field at the magnitude 5 into 10 power 4 Newton per coulomb. So calculate the magnitude of the torque. So what is the formula? P sin theta. So that we can use. So here they have given the theta, that is 30 degree. So we know the formula torque is equal to P sin theta. That is torque is equal to what is P? 4 into 10 power minus 9. E is 5 into 10 power 4. Then sin 30 degree. So we know that sin 30 degree. So then 4 into multiply with 5. So 4 5 is 20. 10 power 5, 10 power 4, 10 power minus 9. So minus 9 plus 4 is will get 5, then 1 by 2. So we will get 1 into 10 power minus 4 Newton meter. So this is one of the example of torque. Thank you.